Hi everyone, welcome back to our second video on variation problems. We're quickly going to describe the procedure for solving any variation problem and then apply this to direct variation problems, since these are the only types we have talked about so far. So this involves four very easy steps. One is to write the equation describing the model. So in the last video we did this with direct variation, and in future videos we'll handle other types of variation. Then you're going to get two sets of data with these problems. One set of data is going to allow you to solve for k, so you're going to have some known relationship between the two quantities, and that will give you the value for k. Then we're going to take this value of k and bring it here and substitute it into the original equation, and then use the data with the missing relationship to solve for the desired quantity. So that sounds a little abstract, but it's really easy to do in principle. So let's look at our problem. We have the height of a projected image varies directly with the distance of the projector from the screen. So at 48 inches, the image on the screen is 16 inches high. So what is the distance, or what is the height of the image when the projector is at a distance of 63 inches? So let's start off with step one. We need to come up with an equation, and notice that this first sentence is just like the last problem from the video. This will tell us the equation that we're going to use with. So we have unknown variables, height of the image and distance from the projector to the screen. So we'll have d for distance. And remember, we have this key phrase, varies directly, which is going to tell us that this is going to be equals k. So when I put this all together, I have the height at the projected screen varies directly with the distance of the projector from the screen. So this is step one. Step two, let's get rid of that, says that at a distance of 48 inches, the image is on the screen is 16 inches high. So this tells us, reworded as when d equals 48, h equals 16. So let's plug that into our equation. 16 equals k times 48. And so solving for k, we get 16 over 48, which is just a third. So that's step two. Step three says take this value and plug it in for k. So step three is just that, so we'll do it. So we'll get height equals 1/3 k. And then the final step, if we go back to our problem, let's see here, is asking what the height is when d is 63. So this is saying, what does h equal when d equals 63? So we plug, sorry, this shouldn't be a k, that should be a d in that step. So what does h equal when d equals 63? So we have h equals 1/3 times 63, and when you figure that out, that's going to be h equals 21 inches. So the image will be 21 inches high. Alright, in the next video we'll talk about inverse variation. See you then.